Okay, so let's see. I wanted to get started in 2.2 homework and just talk a little bit about homogeneous equations. Um, it's unfortunate that they're using the word homogeneous because we're going to use it in another context later. Um, but I just thought I would outline what's happening in the exercises. You'll notice that you're doing one of these problems as a take-home quiz. So I don't want to give away all the fun, but I did want to get it set up. And so in the exercises we're solving a DE by using a suggested substitution. Sorry, I'm not writing my normal way. I'm kind of reaching out here to get this underneath the document camera. Okay, so we're solving a differential equation by using a suggested substitution. In this case, definition, if my derivative of y can be written as a function of y over x, then the DE is said to be homogeneous. Okay. Now notice that there's a couple of e's there, right? Because this isn't the word homogeneous, which yeah, it's different meaning. Homogeneous is going to refer to several things in mathematics, but I'm not gonna say. I've heard mathematicians say this is homogeneous as well. So if you say homogeneous, I'm not gonna say anything, but it really should be homogeneous. Okay. So the way we're going to solve this, we'll solve this by taking the substitution v of x is equal to y of x divided by x. So I'm emphasizing, right, that this y, the original y, was a function of x, and so this v of x, which is y over x, is now also a function of x. Okay, so then we're going to rewrite the DE in terms of v and x. Okay, so well, the first part's easy, right? Since this is y over x, all I have to do is just say this is f of v. Okay, so this is just a function of one variable now. There's no extra x's in there. This is just a function of v. Boom, what am I going to do with this thing? Uh-oh, I'm stuck. Oh, I can use this thing somehow. Okay, so here's y of x is equal to x times v of x. So therefore, what is dy over dx? Product rule. So derivative of x is 1 times v of x plus the derivative of x times the derivative of this, which is v prime of x. Okay, and so on this side of the equation, we would write v of x plus xv prime. Maybe I'll suppress this x notation here. That's f of v. Okay, so therefore xv prime is now f of v minus v. And so v prime is divided by x, f of v minus v over x. What do you notice about this? What kind of a differential equation is this? This is a separable DE. And now we know how to solve separable differential equations. So let's do a particular example here. I don't know if I'm going to go all the way through it. I guess it depends on if you'll find it entertaining or not. Let's see. How about the example dy over dx is equal to y minus 4x divided by x minus y. Okay, So first off, is this homogeneous? Well, it doesn't look like it in its present form. However, if you divide the numerator by x and the denominator by x, what do we get? We get y over x minus 4 divided by 1 minus y over x. And now this is of the form f of y over x. That is, wherever you see the variable in your differential equation, it's of the form y over x. Very good. And now we'll do our substitution. Substitution, v equals y over x, or you could write it as y equals x times v. Okay, and so I need to substitute something for the derivative. Let's just go through that computation real quick again. Y prime is v plus xv prime. Right, I'm using a product rule there. So v plus xv prime is equal to v minus 4 over 1 minus v. Good. So let's do some algebra. V minus 4 over 1 minus, if you're going into engineering, you got to love algebra. That's kind of a requirement. The minus v equals v minus 4 minus v times 1 minus v over 1 minus v. I'm getting a common denominator before I do anything else. What's that going to be? V minus 4 minus v, can you guys see? Plus v squared. V's cancel. Looks like I've got a v squared minus 4 divided by 1 minus v. Good. All right. So here we are. dv over dx is equal to, I'll just go ahead and put my 1 over x like that, times v squared minus 4 divided by 1 minus v. Good. Now if I were, no, now what did we say this was? This is separable. So now we can solve it. So I'm going to go ahead and solve it. I'll take the reciprocal to both sides. 1 minus v over v squared minus 4. dv is equal to 1 over x dx. Okay, I think this is probably as far as I'll go, maybe. Could you integrate this side? How would you do that? How would I integrate this side? There's two ways to do it. Well, I think if you have a polynomial divided by a polynomial, do you remember what happens? I think we have to do something called partial fractions. 1 minus v over v squared minus 4 can be written as 1 minus v over v minus 2 times v plus 2. And using partial fractions, that's going to be a divided by v minus 2 plus b over v plus 2. Did you forget about all that? Oops, I'm writing crooked. There we go. Sorry about that. So now we have to figure out what the a and the b are. I'm going to stop here. I think we may, because this is really an integration problem now, and so we may look at a separate video just going through what it means to do partial fractions. Good. Okay. So see if you can finish that up. We do have, well, you're going to have to do something very similar to this on the group quiz. So work together, and I will see you later.